So far, we have analyzed how to have a feel of slope for lines which can be of 4 different patterns, and they're just like the way we used to learn about lines in our kindergarten days. So let's have a quick look up at the type of lines that we can encounter. So we can encounter 4 different type of lines, and let's see what is our knowledge so far based on the slope of these lines. So my line can be a slanting line making an acute angle with positive direction of x-axis. My line can be a slanting line making an obtuse angle with positive direction of x-axis. My line can be a sleeping line, which means it makes 0 degree with the positive direction of x-axis. And my line can be a standing line, which means it makes 90 degree with the positive direction of x-axis. So let me also plot the positive directions of x-axis parallelly. So if I see this particular line, this is the positive direction of x-axis. 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 Now out here, theta is acute. So slope is positive. Theta is obtuse. And as such, my slope will be negative. These are the natures that I get to get from stage 1 and stage 2. I just get to get the nature. Here we'll get a value. So here theta is equal to 0 degree. So slope is 0. And here theta is equal to 90 degree. So slope is infinity. That's what we have learned so far. What we do today is we try to find out how can we compute slope. In that, we first take our example number 1, okay, and make a line that makes a acute angle with the positive direction of x-axis. So that's our line. To compute the slope of this line, pick any 2 points of your choice on this line. They can be anywhere. It's not that it's necessary it should be in first quadrant. You can have it on first, second, third, just 2 points on the line, and try to first map the abscissa and ordinate of this point. So let me extend this point, right? So let me extend this point here, here on each of the x and y axis and name them. I call this as x1, call this y1, let this be x2, let this be y2. This is point P1 and this is point P2. Now, how do I compute slope? Now, just try and understand. In order to compute slope, first position yourself at P1, okay? You position yourself at P1 and you have to go till P2. Now, only way you are allowed to go is either you can climb up vertically or you move horizontally. These are the 2 motions allowed to you. The 2 motions that are allowed to you are either a vertical climb or a horizontal run. Okay, so what I'm trying to say is that from P1, either you can go in this manner, either you can go in this manner, or you can go in this manner, okay? You are not allowed to move any diagonally. So I'm choosing different colors. So how will I go? I would first climb up, say this way, and I would move this way. You could have also said that, sir, I'm going to go this way, and then I will move this way. That's also fine. That doesn't make any difference. So what is to be understood here is that if you move horizontally, then you will give a name to this motion, and this name would be run. And if you move vertically, all right, if you move vertically, the name that we will associate with it is called rise. And this brings us to a formula of slope. Slope is rise over run. And when we say rise over run, a convention we will remember is if our rise is vertically upwards, we will consider the rise as positive. If it is vertically downwards, we will consider the rise as negative. Similarly, run, if we go on the right side, we'll consider this as positive. If we go on the left side, we would consider this as negative. So, if we now try to compute slope from the above formula, that's from this, the rise will be given by y2 minus y1 over x2 minus x1. I can also call this as the difference of y over the difference of x, delta y by delta x. Now, we'll merge it with our initial concept of slope, that's the indicator of slope, where we say that we take the positive direction of x-axis. Now, this is positive x, right? This is positive x-axis direction, and try to look at this angle theta. If you try to merge little bit of trigonometry with this, then I would also say that delta y, okay, now what is delta y? Delta y is this, and delta x is this. This is also equal to tan of theta, right? Tan stands for TOA, which is tan is equal to opposite over adjacent. That's tan, that's opposite, and that's adjacent. So this is our formula, slope. I'm writing it now. So if you have to ever compute slope, have the analogy of rise over run, in which you'll end up computing the difference over y over x, difference of y over x, right? It doesn't make a sense whether you take y1. Okay, somebody might tell me, sir, if I would have taken y1 minus y2 over x1 minus x2, doesn't make a difference, because if you think that this value is going to be negative, okay, and this value is again going to be negative, the two negatives will cancel up. So whether it's y2 minus y1 or y1 minus y2, as long as you take y2 minus y1, then you should also take x2 minus x1. If you take y1 minus y2, make sure you're also taking x1 minus x2. And this is equal to tan of theta. Now let's see this case for all the four different cases. Let's see it first for, okay, we choose the right combination. Okay, let's see this for a line which makes obtuse angle. So out here, we pick first, we're going to pick 2 points. Okay, let's pick 2 points from here. And the 2 points are, let's say this is 1 point and this is 1 point. Okay, and let me mark their coordinates. Okay, sorry. So we mark their coordinates. So let this be one, let this be the other, this. So I have, say, x1, I have y1, I'm sorry. I have x1, I have y1, I have x2, I have y2. So let's see the imaginary right angle triangle. The imaginary right angle triangle would be here. So whichever side we want to go, if you see, if you are trying to, let's take the approach in this manner. Okay, let's not get confused. Let's approach it from P1 to P2. Now, if you want to go from P1 to P2, then you would find that the rise is negative. Okay, the rise is negative going from P1 to P2. So we find that our rise is negative. However, the run, okay, the run is positive. Right? I'll use a different color to show you that what happened if we would have gone from P2 to P1. Let's say we are going from P2 to P1. So if you go from P2 to P1, then the rise is positive. However, as you run this side, the run would be negative. Okay, so the run is negative. Now this reinforces that if theta is obtuse, then the slope obviously becomes negative. Now just employ your formula. Slope is equal to, one option you would have is either a negative rise over a positive run, or you would take a positive rise over a negative run in either cases. How to see this from the trigonometry perspective? So make an angle with the positive direction of x-axis. So let's say this is the positive direction of x-axis. Now it is tan of theta, and theta is the angle that the line makes with the positive direction of x-axis. Now for simplicity, what we are doing, let's say we assume this as theta, and this is 180 minus theta. Okay, this is 180 minus theta. So our slope will be equal to, not tan theta in this case, it would be tan of 180 minus theta, because we are supposed to take the angle. This is the angle line makes with positive x-axis. Okay, positive x-axis, tan of 180. Now, tan of 180 minus theta is negative of tan theta. And once you have obtained a negative of tan theta, it becomes very easy for you, because whatever rise you are taking is delta y, whatever run you are taking is delta x. So it would be delta y, negative of delta y over delta x. Therefore, you get a negative slope. Fine. You get a negative slope. not that difficult to understand. If at all you think that you got confused, so just think in this manner. The right angle triangle was this sort. Okay. This was our angle triangle. I'm sorry, I drew it in the opposite way. So this is my right angle triangle. And let's say if this angle is theta, then this angle is 180 minus theta. That's it. And this is your delta y. This was your delta x. Let's see. So this was computation of slope for the first case. This is computation of slope for the second case. For the third case, it becomes very easy. Now, out here, theta would be equal to 0 degree, line parallel to x-axis, right? Line is parallel to x-axis. Let's have a quick look how this will be. It's of this sort, right? Our line is here, and let's plot the positive direction of x-axis, and the positive direction of x-axis is here, right? Now, if you observe it from our formula perspective, the slope, pick any 2 points on the line. So let's pick any 2 points on the line. Let's pick this. You will never rise here, okay? Your slope is equal to rise over run. Your rise is always 0. For run, you will have a value. Ultimately, this is 0, and tan of 0 degree is also 0. So this reinforces your finding. Let's see the fourth case. Line is perpendicular to x-axis. So let's see how the scenario looks in that case. Out here, and my line is out here. Let me draw the positive direction to x-axis. The positive direction to x-axis is out here. Sorry, I'll take a different color. Okay, positive direction to x-axis is here. Okay, now this is theta equal to 90 degree. Pick any 2 points out here again on the line. Let's say these are the 2 points. Now, if you try to calculate slope in this case, okay, you would have a value for rise, but you will have nothing for run, and anything defined by 0 is undefined. So this is, either I'll call it undefined. This is an indeterminate form, or you call it that the slope is infinity. And if you take tan of 90 degree, you still get infinity or undefined. So that's it. Have a quick summary out here. The summary of our learning on this part is, remember it in this way, that slope is equal to rise over run, okay, with the criteria that rise upwards is positive, rise downwards is negative, run on the right hand side is positive, run on the left hand side is negative. Slope is also equal to the difference of the data on the y coordinates over the difference on the x coordinate, and slope is also equal to tan of theta. Again, be very, very careful. Theta is angle between line and positive direction of x-axis. Right? In our next section, we'll focus how we employ these learnings to solve or understand basic aspects of physics in kinematics, where we see motion in one dimension, as well as certain aspects of current electricity, where we see how we can employ slope in learning some aspects of Ohm's law.